up, everybody? Welcome to another episode of Coffee Hour. My name is Paul Abernathy. Welcome to the show. Glad to have you here on this Thursday, which is the 15th of May. And we're getting started, getting towards the end of our week. We have one more day to get to the end of the week. So, hey, welcome, and glad you made it this far. Also, as always, do me a favor, let me know in the comments who you are, where you're from, what you got going on. And if you have any questions, feel free to post them in there if they're germane to the topic. We are still in the series of services and electrical equipment. We'll be at part 7 today. We're going to talk about some grounding and bonding things in today's episode. So make sure you join us. Also, it's kind of one of those things where we have a lot going on here. So also wanted to mention that we do have 2 new items that are available over on fasttracksystem.com, which is the flashcards as well as the 25 question database. In case you didn't see that, we will be also adding that next week to the wheel. So it will be something that is an instant win type of thing. So if you want those flashcards, or you may get it, that type of thing. So we'll be adding that as well, that type of thing. All right. So, any rate, again, thanks for joining me. As always, hopefully you share it with other folks. And we can agree to, in many cases, we can agree to disagree on a lot of things. It's kind of funny because sometimes I'll post comments to different things, different platforms, and I have to be careful because sometimes I'm talking code and I'm interjecting, and then I'm also talking about discussions that we may have had maybe in a panel meeting or a code panel meeting, and I'm sharing that information. And I do have to be, make sure I got the right glasses on. I have to be careful. For example, an individual had a post in I think it was Instagram or TikTok or one of them about free conductor. And one of those things is I started to give the code and then, kind of interjected into conversations that we had on Code Panel. And then I realized that I was doing that. And I said, you know what, I better remove that and take it off, or at least let the guy do his thing rather than jump on him, because he was educating and giving people insight. But, you have to weigh those type of things, especially when you're commenting or making reference to folks. For example, the question or the image, I don't know if you've seen it, was in a box. So you have a box it's a metal box, and you have an MC cable coming into it, and you have the conductors coming in, and the code requirements at 300.14 is that you have 6 inches of free conductor. And free conductor, what's interesting about this is an interesting interpretation, is that some people will say that you have to have 6 inches of free conductor before you do anything with it, right? 6 inches of free conductor coming into the box. And of course, y'all all know that we can splice that now to get our 6 inches if it happens to be too short, that type of thing. Y'all know that we can do that. Now you can. It was something that was always done, but kind of tongue-in-cheek type of scenario. But anyway, the gentleman put out a video and said that the portion that comes out of the cable can't wrap around a ground screw and then continue on, and the argument is that's not free conductor. Well, my argument in a code panel, and I'm not certainly not speaking for code panel 5, certainly would never do that. But you had the 6 inches of free conductor when you came out of the cable. And it's usable. And if I'm required by 250, 148, and 146, and all these, I'm required to bond that metal box to the equipment grounding conductor. So it's one of those things in the code. It seems silly to say that I got to have 6 inches of equipment ground before I can do anything with it, right? You get what I'm saying? It's one of those things where you're like, so it's very common for electricians to come out and take their equipment ground, right? Strip off a little bit of it if it's insulated, which for the most cases, it's not required for MC cable to be insulated, the equipment grounds. In bigger cable, it's not. But in the smaller cables, it's typically going to be insulated, right? So one of the common things to do is to come out with the equipment ground, and maybe 3 inches in or so, they will take it, strip off a little bit of the the insulation, and wrap it around the ground screw that's in the box. That's the screw that's listed for the box. Wrap it around it, and then continue on. So it's for the device, right? And one of the common things, and his point was that you can't do anything to that equipment ground for 6 inches. So you have to have at least 6 inches before you can do anything to it. And I kind of disagree with that concept. If the whole purpose of that equipment ground was to bond the box and to bond the device, I'm required to have 6 inches of free conductor at rough end, right? Or I'm required to have 6 inches of free conductor coming in to be able to use to do what? To bond the box, to bond devices, that type of thing. The other part of that rule is if it's a smaller box and it has to be able to access it and get a device to be able to make a turn, it also requires that if the box in any dimension, okay, is, I believe, less than 8 inches in any dimension, which a 4x4 would be less than 8 inches in any dimension, that you also have to have at least 3 inches sticking outside the box, clearing the box, right? So by proxy, you're going to have your 6 inches. And so the argument here is, do you have to have 6 inches of conductor that nothing is connected to? And then you can connect stuff to it and bond the box? Or the intent is to bond the metal box, and that's what the equipment ground is there for, to bond the box, to provide a low impedance effective ground fault current path, and to terminate onto the device. So the question is, can I wrap it around a screw within that 6 inches? And then some people will say no, because then that gives me less than 6 inches of free conductor. And that's just, because they're using the term free conductor means it's free willy, that type of thing. And hence the name, hence the free, right? And of course, I had to realize that I want to be careful when I'm talking to the guy, because that's his interpretation of it. And that's fine. And you say free conductor. I believe you had free conductor. I believe you had 6 inches of free conductor. You just used it as its intended need to bond the box. And you use the rest of the conductor to go to the device. And if the box happens to be, and it says at least 6, so you could have more. If you're bonding the box and you're taking a device, then it also, again, if any dimension is less than 8 inches, okay, which a 4x4 would be, then you have to make sure that equipment ground extends out beyond the box at least 3 inches, which is going to give you adequate to be able to make these connections, that type of thing. So that's just what I believe. And so that's a great example. But I realized that I don't want to, that's his interpretation. And I get it. And it might be a lot of people's interpretation that's free conductor. For me, I look at it from a perspective that it's the equipment ground. I know what its function is. And I've got 6 inches. Now I'm going to use it to bond the box. Now, where I would have a violation was if I brought out 3 inches and then I bond the box and I stopped. And that's it. That type of thing. So just happens to be how my opinion. So I realized on the gentleman's thing, I was like, you know what? I don't want to interject my opinion into it, because his opinion is free conductor means it's free conductor, means it's free, it's free floating, right? But there's no definition in Article 100 of free conductor. There's no definition that says that 6 inches of free conductor, that I can't use it within the 6 inches to bond the box, that type of scenario. So, if I was bringing it into a box and I was looping it through a connector, and it had a lug on it for just some reason, I'm bonding, does the measurement stop at the lug, or if it's unbroken, it continues through? It's still 6 inches of free conductor, whether it's terminated something. The key is as long as I have enough to be able to make my additional terminations. And in that image that he showed, he had more than enough beyond where he wrapped it around the screw in the box, right? So, but it's kind of those things where you have to be very careful when you comment on stuff like that, because first of all, I don't want to hurt a legitimate code video that's really trying to teach somebody something rather than some of the comments you see. So I have to be careful how I comment it, because at the end of the day, I still saw it as 6 inches of free conductor. I just saw that it's being used for its intended purpose, even though it wasn't all the way to the end, that type of thing. So again, as long as I have the amount outside of the box, 3 inches extending beyond the front of the box, and as long as overall I have 6 inches, whether they're using it or not, I still think it's the intended purpose. I need at least 6 inches to be able to use it to bond the box and to get to a device. So for me, I think that's the reason why they also require the additional 3 inches for a box that is 8 inches or less. Okay, I'm just saying. All right. Anyway, that was my thought. If you actually go over, I don't know the video where it is over on there, but it is over on Instagram, not Instagram, maybe on TikTok. Maybe it's on TikTok or something like that. All right, let's do some shout outs real quick. We'll get into today's lessons, get some grounding and bonding. Again, if you have any questions, feel free to ask them. I'm more than happy to give my opinion, my thoughts. I don't always say I'm right. Again, this is a misconception. I am a target for haters everywhere. So if I'm giving an opinion or talking about something or whatever, it's almost like people hunt out to be able to say something negative about me or whatever. So I get that. And you know what? And I'm okay with it. The moment that I started reading all the comments about Trump, whether you like him or not, I realized that it doesn't matter what a man does or anybody does, you're going to have haters. So you don't worry about them. And I don't worry about them. So you can agree to disagree with anything I say here, or you can choose not to follow me in the morning or whatever. That's your choice. And I also do not think that I am right about everything. Okay? Another misconception. I learn something every day. I may disagree with something, and a lot of the disagreements come from my my discussions at code panels and meetings and topics, and I've sat in a room and seen obviously two experts disagree on something. I watched a code panel hearing where, you know, when you run a grounding electroconductor through a Ferris raceway that you have to bond both ends, right? But if that raceway is connected to the metal enclosure and a service, and then that metal enclosure is bonded with the main bonding jumper to the neutral, it's all acting as one, right? But the code says you have to bond the grounding electroconductor to each end of the raceway. Well, at the end that's down near the electrode, that's a no-brainer, right? Use one of those clamps that physically connects the grounding electroconductor to the Ferris raceway, like an EMT, right? Not a problem. But the other end that connects to the box, right? They're saying, no, you got to put a fitting on it and then loop the EGC through it, because that fitting it needs to connect to the other side of the raceway. But yet that raceway is connected to the metal box, which is also connected to the grounded conductor through the main bonding jumper. So it is all acting as one. So once that GEC comes out and goes to the bus, it is technically connected to the other end of that raceway, right? Well, I sat in a code meeting and people, and Ryan Jackson was the one that submitted this. I watched the meeting and everybody say that in the meeting that no, it has to be physically connected right there at the point where it comes in, only to have the other half of the room say no. And then when we went on break, I asked the people that said that it had to be connected to the actual grounding electroconductor as it comes into the cabinet. I said, are you saying that you literally have to put a lay and lug there so that it physically can? And I explained it and they go, oh no, it's okay terminating to the bus. But right during the meeting, some of them argued that it had to be connected to the GEC at the point where it enters into the cabinet. It doesn't say that. It says it has to be connected to at each end to the GEC, but it is in the cabinet through the bus system. So it's just an example where it can be things can be argued. And again, that's the beautiful thing. We don't always have to agree, but at the end of the day, we do come to some type of consensus on stuff. Hey, by the way, make sure you check out, right there. Check out Fast Tracks Tube. Watch the videos on there. If you get a subscription over there, your subscription is for Fast Tracks Tube. It is not for Fast Tracks System. It is not for anything else. It's not for courses. It's for the video platform. Now, of course, if you purchase our Fast Tracks Enhanced programs, whether it's a 2020 or 2023, you're going to get access to that as well, included for 1 year, that type of thing. And if you join us here in the spin, you might win a free subscription to Fast Tracks Tube. And if you already have it, you can get an extension, right? And I keep record of all this. So if you say, Paul, you didn't extend mine, don't worry. We keep records of everything and everything you win. So don't worry about that. Let's do some shout outs real quick. What's up, Brandon? Joining us from Houston, Texas. Okay, Paul, your neighbor. Paul, Brandon's your neighbor down there in Houston, Texas. Welcome, Paul. Glad to have you here. Marlon, glad to have you here, Marlon. Thanks for joining us. Manny's in the house wearing that Code Nerd green representing. What's up over on our Facebook channel? Glad to have you here. Good morning, Frank. Glad to have you here. What's up, Rob? Good morning. Glad to have you here. Oh, one more day to the weekend. That's what I'm talking about. It is raining like crazy here. I'm good. We've got floods. The water's up like crazy. It's funny. I'm in Texas, and we hardly ever get any rain. We're always going, damn, it's so dry. The moment we move back to Virginia, it's almost like it's nonstop rain. Crazy. Two dynamics difference, going from dry, hot to here. Okay, but we love it. Glad to be back. What's up, Manny? I'm with Jeff and Andrew in the work truck. Sweet. Andrew, Jeff, welcome. Hopefully you join us in the future. Glad to have you here. What's up, Nepo? Glad to have you here. Brandon's question says, question on 12.2 NMB, is a white conductor a neutral or just a grounded conductor? So in typical applications for non-metallic sheath cable, the intended use is typically residential. And so these residential systems are 122 40 volt systems, so they're intentionally grounded. So that is a grounded conductor, but it also is a neutral conductor. Okay. So now you're talking about in a 12.2 itself. Okay. So in a 12.2 itself, what's going out is coming back. So typically in a 12.2, it is a grounded conductor. It's not necessarily a neutral conductor, okay? But at the end of the day, when it comes to a 122 40 volt system, we use the terminology synonymously, okay? So we have definitions of neutral, okay? And we have definitions of a grounded conductor. The fact that all of those systems that are grounded systems, the grounded conductor is intentionally back all the way through the panel to the bus, which is connected to the grounded conductor that's coming from the transformer, which is intentionally grounded to earth at the XO to earth. That's a grounded system. So it is a grounded conductor. Okay. Now, whether it's a neutral or not, again, it depends on its application. But in that effort, it's a good start real quick. And I'll finish some shout outs real quick. Hold on. In that effort, we're going to show you, I'll go on and show you, let's see, where do I want to show you? Something I was going to show. Let's see here. Let me see if I can get my brain working to where I want to show you. Yeah, let's go here real quick. And I'm going to go here, quick here. All right, so just 310 feet. So I just wanted to show you, let's see, let me get down here, neutral. Okay, so this might help you out, Brandon, a little bit. And remember, Brandon, you're doing the calculations now. So don't get bogged down in code questions. You're not going to get those in the calculations. Focus on calcs. But what is going to help you, if you want to know whether or not it's counted, for example, as a current carrying conductor, those type of applications, it's important to know these things. So here's 310.15e. It says a neutral conductor shall be considered current carrying in accordance with any of the following. Notice that it says a neutral conductor that carries only the imbalanced current from other conductors of the same circuit shall not be required to be counted. That's like a multi-wire branch circuit. Say you have black and a red and it's carrying the white. It's carrying the imbalance. okay, it does not get counted as a current carrying conductor, right? Right? But in a normal circuit with just a black and white of a 12-2, if 10 amps is being drawn on the circuit, 10 amps, it's 10 amps. What's going out? It's coming back. It's going out, coming back. So in a 12-2, the white is indeed a grounded conductor, okay? But it is also considered a current carrying conductor, okay? So so if I have a 12-2, I got 2 current carrying conductors in that application, okay? Now, as far as definition, always important for us to focus on definitions, okay? If you go down and you go into definitions, and we just go down, let's see here, just so you can see what, okay, let's see here, just real quick. So here's grounded conductor real quick. Good lesson this morning, okay? So grounded conductor is a system or circuit conductor that is intentionally grounded. Okay, so we can call in all residential applications, right? 120, 240 volt situations like that. Even a 277, 480, 277 is grounded. So in that scenario, you get a grounded system, right? It's intentionally grounded back at the transformer. That's where it takes place. XO, there you go. So, and then of course you have your GEC, which is making its connection to earth for earth reference, okay? So, it's a grounded conductor, but not all grounded conductors are actually neutral conductors, right? So they're all grounded conductors in a grounded system. Those neutrals are also grounded conductors, but in some systems like a delta high leg, it's not always, or excuse me, an open delta, should say it that way. An open delta is not always a grounded system, okay? You could have a corner grounded delta, but typically just a delta system, okay? So anyway, let's go here real quick, and since I've got you, and I know you're heavily in your studying, so let's go into right here. So here's a neutral conductor. Let's look at the definition. So we know what a grounded. So a grounded conductor is a conductor that's intentionally grounded to be in a grounded system. Okay, a neutral conductor is a conductor connected to the neutral point of a system that is intended to carry current under normal conditions, okay? Right, so that's a neutral conductor that's carrying current. So it is the way that system is set up, and the neutral goes all the way back to, goes out and back, goes all the way back to the bus, connects to the bus. It's connected to the grounded conductor that's coming from the transformer, which is connected to ground. Okay, and it is carrying current. So a conductor connected to the neutral point of a system that is intended to carry current under normal conditions is a neutral. The question is, so it is a neutral in that 12-2. It is a neutral, okay, because of its connection. It is a grounded conductor because of the system. The question really becomes for somebody that's studying like you for an exam is whether or not I count that conductor as a current carrying conductor. That's the key topic. That's the thing that you have to think about for exam. And again, if it's carrying the imbalance, like in a multi-wire branch circuit, it does not. If it's in a 14-2, 12-2, 10-2, for example, then it is carrying the same amount of current as the hot conductor or the black conductor. So then you count it as a current carrying conductor. Does that make sense? All that makes sense? All right, let's get back to some shout outs real quick. I want to make sure I do some shout outing. What's up, JPB? Glad to have you here. What's up, Mason? Glad to have you here. Good morning, Battles. I see you on multiples. What is it? Angry Pixie Tamer. There you go. Good morning, Seattle or Skiattle or however it is. What's up, David? Is it a beautiful day down in Florida? There you go. What's up, Two Guys Handyman? Glad to have you here. What's up, Leroy? Glad to have you here. Oh, and I will say, what's up, Haas? I will say the haters were in effect over on YouTube channel. They must have watched my video must have watched our show yesterday when I was, setting the porter straight. They didn't like it again, so they came out in force. Nasty. That's okay, because every time you do, I just block you. So anyway, you ruin an opportunity to learn. What's up, Joel? What's up, Tino? What's up? Good morning, Erie. Glad to have you here. What's up, Joseph? Checking in from New Jersey. There you go. Good morning, Adam. Glad to have you here. I am doing well. Cannot complain. What's up, Cray Cray? Cray Cray's in the house. What's up, Peter? Good morning, Peter. Glad to have you here. What's up, Edgar? Good morning. Wow, got a lot of folks in here today. What is up, Val? Glad to have you here, Val. What's up, Tara? Glad to have you here. Let's see here. Adrian's in the house, throwing up the hashtag win, getting in on the spin. What's up, Rob? Glad to have you here, Rob. What's up, AJ? Glad to have you here. Santana, you're new. Welcome, Santana. Let me give you a little bit of
woo, 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 woo. Big dog.
There you go. Paul, I get you. Exactly agree. What's up, Derek? From Chicago. Going to be in Chicago in, what is Chicago? For NECA. I think NECA's going to be in Chicago. I'm going to be there. If you go to the NECA show, if you come into the hearings, look me up. I'll be at the hearings. What's up, Alex? Glad to have you here. Thomas, glad to have you here, Thomas. I don't know if you got your email or not. You were successful on your retake, and all we're waiting for you is to pick a time and during the week that you want to do your proctored recorded exam. So go check that email. I did send it out. Let me know you got it. But congratulations to Tom. He's worked his way through all of the units in the CMECP program. So he's got the legwork out of the way. Next, he has a proctored exam, 100-question exam, and then he's got his essay. So there you go. He's on his way. There we go. Thomas says electrically continuous. Yeah. What's up, Red Dog?
Woo, 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 woo. Big dog.
What's up, Angel? Glad to have you here. Good morning, Gregory. There you go. Good morning. David in the house. David, I sent you a reply back. I don't know if you got it. About give me a call when you get a chance. What's up, Ryan? John, welcome. Good morning. Yep. Hopefully you got your answer, Brandon. What's good morning, Anselmo? Glad to have you here. Wow, we got a lot of people. What's up, Charlie? Glad to have you here. Let's see. All right. Kind of caught up. What's up, Jonathan? All right. Kind of caught up. So we'll get into some grounding when it comes to electrical equipment and panels. Again, very high level view. Again, if you have questions, you know what you can do. Post them in the comments, or you also can go to paulabernathy.com, submit them that way. I am behind on my podcasts. I tried to sit down over the weekend and do some podcasts and get caught up with that, and I just couldn't get caught up with it. And so I have some in the can that we've recorded, but just wasn't able to get them released. So make sure you listen on the podcast, because you'll get notified if you're subscribed when they come out. All right, let's get into the lesson today. So let's talk a little bit about grounding, okay? And I'll zoom in where I need to. And if you got any questions about grounding bonding, please feel free to let me know, that type of thing. So it says equipment grounding conductors, grounding electrode conductors, and bonding jumpers shall be connected by one or more of the following means. Right? So this is 250.8a. So this is that kind of that list. Okay, that type of thing. Now, sorry, Brandon, we can't tailor coffee hour to just try to get your fill in calculations. There are plenty of them over in Fast Tracks Tube, single family, the multifamily, the bunch of different calculations. There's an 8-hour calculation video over there that you should watch. It's a full 8 hours, that type of thing. I mean, if there's a specific calculation and you send it in to paulabernathy.com, we might be able to cover a topic, but calculations is too broad. I'd have to know exactly what calculation, and we've already covered things like, go back and watch episodes. We've covered single family dwellings. We covered multifamily dwellings. We did a whole week on each one of those. So I can't get redundant. We've done a whole week on motors. So they're all out there. So I've already done those things on coffee hour. You know what I'm saying? So they're out there. You just have to go looking for them. They're on our YouTube channel as well. So All right, so equipment grounded conductors, all these type of grounding and bonding has to use the methods that are listed in 250.8a. Okay, so you've got what's called listed pressure connectors. We've got terminal bars. We've got pressure connectors listed as grounding and bonding equipment with exothermic welding process. We got machine screws, tight fasteners that engage not less than 2 threads. Okay, so basically they're tapped. And so it's going to be very tight. That's why like an 832 or 32 actual ridges of the screw per inch. But it's designed, it's tapped into an enclosure. Okay, that would be fine. Or if it's not, then it can be secured with a nut, that type of thing. So you also had thread forming screws that engage not less than 2 threads that basically form it as it taps it. There's many options here that you have. 7 connections that are part of a listed assembly, something that's already built into the assembly, already designed into the device, things like that. It's already covered. And then 8 other listed means. So the list, by the way, the list is, let's see here. Let's go down. Let's just look at the list real quick so you kind of have a better understanding of the list here. So here's the list that you can see. And so this gives you the permitted methods. And this is going to cover, right? This going to cover the screw, wire nuts, wire binding devices, all those type of things. Wagos, whether you like them or not. Lever action Wagos, pressure push-in active Wagos, wire nuts, all those type of things. Terminals, that bus bars and terminations in bus bars, using a bus bar for terminate, all that's covered here. Okay. So there you go. This is an interesting one right here. See this? See this screw? Okay. There you go. This is your metal box. This is your equipment bonding jumper. All right. That type of thing. Here's another type right here. This is those metal clip type right here. That type of thing. The equipment bonding jumper. This is a grounded metal box. Yada, yada, yada. This is self-grounding. If this is a self-grounding screw, then this is not necessary, right? If this is a self-grounding receptacle, that type of thing. Let's see here. All right, so you have different applications, all right? Incidentally, also this screw right here does not have to be green. I knew people ask that all the time. This does not have to be green. This has to be green. This does not have to be green, okay? Okay, so those are the different types of things. Listed pressure terminal, okay? Pressure connectors, like a wire nut, a wire binding device, those type of things, okay? All right, get back to the lesson here. All right, and an AC system grounded at any point and operating at 1,000 volts or less must have a grounded conductor that is routed with the ungrounded conductors to the service disconnecting main. So typically in all the systems that we deal with, we're dealing with an AC system that's a grounded system, that 120, 240 volt, that 277, 480, those typically ground systems. So coming to the service, we have to bring a grounded conductor. And again, it's a grounded conductor because it is intentionally connected to ground at its origin, okay, back at the transformer, okay? So it's intentionally grounded, and that's kind of the definition of grounded conductor, right? So it has to be routed to the service equipment. Now, this is one question I get from people all the time, is that, okay, I'm required to bring that grounded conductor there, right? And what's up, Ron Bo? Glad to have you here. Thanks for popping in. So while you have to have the grounded conductor, many people ask is, well, what if downstream I don't need a grounded conductor to a motor or a piece of equipment? Is it okay to not carry the neutral to a piece of equipment? And the answer is yes. If the piece of equipment doesn't require a neutral or doesn't require a grounded conductor, now it's still going to require equipment ground. That's different. That's why terminologies are so important. but it's not going to require a grounded conductor, which may or may not be a neutral, depending on what you have at the load. So if you have a load that does not require a neutral or does not require a grounded conductor, then I don't have to have one. This is also why you see people say, well, I run 4 conductors to a range, I run 4 conductors to a dryer, and they're thinking, well, why do I need the neutral there? Well, you need the neutral. In this case, it is a neutral because it's carrying the imbalance, okay, of the actual 2 phases. And so you need it there also because you have 120 volt loads there. Okay. And so, and because that's intentionally grounded, it's all about the potential. So 240 is the potential between 2 conductors, and the 120 is the potential to earth or to the earth reference. That's what stabilizes the voltage and gives us 120 or right about there, nominals. And you need to have it there because there's also different things like the timers and electronics and all that kind of stuff, right? That are associated with those appliances, right? And so that's why we have it there. But there are other things like motors that won't need a neutral at all, right? Or won't need a grounded conductor. And now they all need an equipment ground. Still got to clear an overcurrent device, okay? And so we can't intentionally use the grounded conductor, or in cases with neutral, we cannot use that downstream of the service to make connections to metal parts, okay? That was done prior to 96, but you can't do that anymore, right? So that would be a violation of 250.24b, right? All right, so it says, where are we at? Back to the lesson. An AC system grounded at any point and operating at 1,000 volts or less must have a grounded conductor that is routed with the ungrounded conductors to each service disconnecting means and connected to each disconnecting means grounded conductor's terminal or bus, right? So right here, hard to see in the image, but there's your meter coming out. It's coming in, and right here. So this is your typical residential meter. Who let the dog out?
Woo, 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 woo. Big dog.
So right here is your meter, and it carries the bonding jumper. Now, typically in the meter, in residential meters, by the way, this is usually taken care of because the neutral point here, or the connection where the neutral connects, is already connected to the enclosure. Of course, it's easy to detect that with a continuity tester. You could test that from the enclosure over to neutral to see that it's already done if you ever want to do that to see. But typically it's done inside of the meter and you don't have to put any jumper. It's already done. But they do make meters that are designed for use in tenant side stuff, which may have the neutral floating. So again, be careful. You know, typical meter that you would use for your service is not going to have a problem with that. So this, anyway, coming through, and again, only thing that's being shown here is the grounded neutral conductor, okay, in this scenario. All right, so it comes over here, and here's the bus. The bus, this neutral now is connected here, all right? It's connected through here. And this is a main bonding jumper, which is going to be the linkage that connects this enclosure to this grounded conductor, in this case a neutral, through the neutral bus. And this is where you're going to put all your grounds, your equipment grounds from your circuits that come out, as well as your neutral connections connect here in this service equipment, okay? Keep all that. All right, it says a main bonding jumper shall connect the grounded conductor, okay? So you have to have this main bonding jumper, grounded conductor to each service disconnecting means. So you have to have this connection. Now, this does not always have to be a screw like it's shown here. It's a green screw. Now, the screw is required to be green in finish. So this is the other area where the device is, the screw has to be green, and it's on the device. The boxes, the screw that would mount, which you would maybe connect the EGC to the box, does not have to be green, okay? But it does have to be green for this main bonding jumper if you're going to use a screw, okay? But there are other methods to do this. I mean, you could use the wire type, and a lot of the images that we show in our program, we actually separate the buses out. And so there's a wire that connects the the bus that would get equipment grounds and the bus that gets a neutral. Now they're bonded together, so they act as one. That means that conductor that connects them together is a main bonding jumper, and it's of the wire type, and it has to be sized accordingly because over on the grounding bus, it's connected to the enclosure, and it intimately connects the grounded terminal bus together, that type of thing. So it makes them act as one. We show that in a lot of images because we're trying to illustrate that it doesn't just have to be a screw. That would just be too easy all the time to do that, right? That type of thing, okay? And here's an example right here. So this would maybe a bonding jumper. It could be utilized depending on if you had a raceway coming in or whatnot, that type of thing. Let's see, let me get this back real quick. So this illustration is really just trying to show you all the pieces. That's all this is. It's showing you there's the neutral. It's showing you bonding jumpers. It's showing you main bonding jumpers. It's showing you meter socket, yada, yada, yada. That's all it's really trying to do. It says the grounded system. Okay, so this is an intentionally grounded system, say a 122 40 volt system, let's say. The grounded system must have an unspliced main bonding jumper connecting the equipment grounding conductor, okay, and the service disconnect enclosure to the grounded conductor within each service disconnect enclosure in accordance with 250.28 and 250.24c. Gives you the parameters, that gives you the rule, and then of course, in accordance with 250.28 describes what a main bonding jumper is and what it can be. In this case, it's just a screw, okay? So a main bonding jumper is the connection between the grounded circuit conductors, and in most cases, a neutral, and the equipment grounding conductor or a supply side bonding jumper, or both at the service. So that main bonding jumper is so critical because how many times have you heard this old saying that electricity is trying to get to the earth and things like that? And you know that's not true, right? That it's trying to get back to the source. Even fault current on a system is trying to get back to the source. That's what allows the overcurrent protected device. So the integrity of the path all the way back to the source, which is the transformer, that's derived from a secondary of a transformer, the whole purpose of that main bonding jumper is to allow that to facilitate it getting back to that grounded conductor that gets all the way back to the source. Now, if you complete that circuit and you have some kind of fault condition, then it's going to allow that energy to skyrocket wherever the fault is. And ultimately what that's going to allow is the overcurrent protected devices to do their thing quickly. If there's an opening in that path, then it can sit there idle and create energized parts, and it's not. So when you see folks like me and others out there harp on main bonding jumpers, and even in remote distribution panels where somebody has the screw they left in it because they used a panel for a remote distribution or sub panel that some people say, or a remote load center, and we see that green screw and you wonder why we jump on people or say things about it, it's not because we want to be a prick. The reason we say that is because images are hard to depict anything. Okay, images being an image, okay? And at the end of the day, somebody could come along and screw that back in. Although we're not inspectors. But when that screw's in there, it's implied that if it's downstream and you leave a main bonding jumper in there or that screw in there, then it's implied that that bus is being connected to the enclosure. And again, we have to separate. Now, whether or not I'm using the equipment ground terminal bus in that screw to make its connection, that's not going to be a problem, okay? It's the neutral bus that has to be elevated in a remote panel downstream of a service, okay? So a feeder panel. And so that's why you see us harp on those type of things. But that main bonding jumper is so critical in the service equipment of a grounded system in order to facilitate the operation of any of the overcurrent protected devices, that type of thing, okay? Think of it like a switch on the wall. If the switch is open, the light won't come on. Okay, it's not completing the path. Same concept for the fault current. Same principle. Okay. All right. So where are we at? So in case where the main bonding jumper or the system bonding jumper is a screw, it must be identified with a green finish that remains visible after the installation. Okay. All right. There you go. Okay. What did Fernando say? Fernando, I got to read it because if I put it on the screen, it's going to jump away. It says, when looping the EGC around a ground screw and continuing in the 1900 box, does the 6 inches of free do, Fernando? Did you not just hear me talk about that? Free applied to the section of EGC from the point where enters the screw or not? My opinion is it does not. My opinion is that you have 6 inches of free conductor coming in. Once it enters the box, I have free conductor. What I use it for is the intended purpose to comply with 250-146 or 250-148, and then use it to make that connection. There are many people that will interpret that you need 6 inches of free conductor like it's free willy. You can't do anything with it until you get to the end of 6 inches, okay? I just happen to disagree with that because I believe that if it comes in and it runs around a screw, that I'm using it for its intended purpose, that I still have 6 inches of free conductor, okay? But I'm using it for its intended purpose, to bond the box. Now, the fact that the code takes care of that is the fact that when we have a box that is less than 8 inches in any direction, you're required to have at least 3 inches that stick out beyond the surface, the front of the box. So it's going to give you more than enough to be able to make connections to devices, that type of scenario, okay? So again, it all depends on somebody's interpretation. There was a gentleman that did a video on TikTok, and I jumped on him at first, and I'm like, you know what? That's not my place to do that. I try not to do that, and I especially don't like to comment on TikTok anyway, because he had good intentions, and he was doing, but I believe that yes, 250.146 and 148 does not remove the general requirements, for example, that we would have in 300.14 of free conductor. But I believe that once that free conductor is in the box and I leave myself 6 inches, that my intent is to use it to meet the intent of the code, which is to bond that metal box. So whether I wrap it around a screw or not, to me, it's irrelevant as long as I meet the other rule in those small boxes so that I have at least 3 inches that extends beyond the front of the box. That is my thought on it. But I am in no place. I have to remember that that's his interpretation, and the code doesn't. All the code says is 6 inches of free conductor. How I use that conductor is what we're talking about. So can I, if you think about the implications here, can I bring in a conductor in and loop it through a bonding bushing? It's not free conductor anymore. It comes in, and maybe it comes in, and you guys do this all the time at transformers that maybe only has 2 inches before it goes through a lay-in lug, though it goes through a termination. It's not broken. It just goes through it, right? Does that mean that you can't do that? So that means that everybody out there in every application where they come from a transformer, okay, and they come in, can you no longer do that? I mean, you have to think about this. I didn't want to be negative to the guy because he's got his opinion, and I had to be careful, okay, because I'm already labeled an asshole anyway from most people. So the fact of the matter is, first of all, do I have 6 inches of free conductor to meet this rule in the box? Yes. I think the next step is what I do with it. And I think that the next step is the 250, which is what you have is the prescriptive methods that you do, and you have the performance. You have performance and prescriptive methods. Once I've got that 6 inches of free conductor, in my opinion, I've already met the rule. Now I'm using that free conductor to bond the metal box to meet the rules that I'm required to meet in 250. So that's how I look at it. But I get it. If you want to enforce that you need 6 inches before you do anything, that's okay too. I'm okay with that. But remember the consequences. The consequences are everybody that's out there that is using, that are doing that free conductor that's coming in from a cable, okay? Then under this thought, you could never bring it in and loop it through a fitting or loop it through a lay-in lug at the moment that it comes into a cabinet or a box. Because at that point, you don't have 6 inches of free conductor. I personally don't think that was the intent. I think the reason they want you to have 3 inches outside the front of the box, right, is so that you can work the device. And that's why they do it. The other thing is, free 6 inches is, say your box is greater, okay, greater than 8 inches in any direction. Then you have 6 inches of free conductor. If I happen to use any part of that conductor, right? I know it makes me sound like I'm an NEC. That is one of the things about the NEC, right? Is you have the performance requirements of 250.4, and then after you leave 250.4, everything else is prescriptive. It tells you what to do, like on a prescription bottle, right? But at the beginning of 250.4 and grounding and bonding, it says, look, if you do all these things later that you're prescribed to do, then you're going to meet the performance requirements. And that's how 250 is written. And so that's why I think that I already met the 6 inches. I'm now using it to meet the prescriptive and the performance requirements of 250. So that's why I'm okay with it. But then I realized that that's a gentleman's video. He can do anything he wants. I don't want to be the negative guy in that video. When somebody's clearly just off base, I'll do it. So I didn't want any disrespect. So I went back and again, edited it. And of course, I'll have the haters out there that say, oh, Paul was wrong. He edited his post. You know what? If you go crawl back under your rock, because that's our job. We are constantly trying to educate and learn, and we can change our mind. I didn't change my mind. I just realized that I respect what he believes. But under his concept, I can tell you there are millions of applications where people are bringing in conductors and wrapping them through a lug the moment they come into the box. In fact, there are many applications where they'd be creating a violation if they followed that strict thought process. Okay, so that's all. Hopefully, that answered your question, Fernando. I didn't want to be hater to the guy. So I edited the comment because I don't do a lot on TikTok, and I get hate anyway, so I don't care. But I just wanted to remember that he's entitled to his opinion, and I don't want to be. He's taking free conductor literally, meaning I can't do anything with it until after 6 inches, right? And I'm okay with that. I'm fine. I don't believe that was the intent. I believe that once I've got my 6 inches, I can use that 6 inches to do what? Meet the performance and the prescriptive requirements of 250. That's what I believe, personally. Okay? That's just how I believe it. Doesn't make me right. That just means that's what I believe it needs to be done. Okay? All right, so where else are we at here? Okay, so the main bonding jumper and the system bonding jumper. Again, system bonding jumpers being for separately derived systems, but you can also have system bonding jumpers, for example, well, a generator would be a separately derived system, depending on how you do the transfer switch, right? Let's see, what else? Transformers, except for auto transformers, all transformers are going to be separately derived systems, even though their equipment their grounding and all is intimate. It's the primary to secondary isn't, so they're going to be separately derived systems. So again, not all generators are separately derived systems. Your typical generator that you'd have in your backyard, which is an optional standby system, they're probably 99.9999999% of the time, you're not going to be switching the neutral, so it is not a separately derived system. You basically treat it just like you would, and I tell this to people all the time, to make life simple. To make life simple. Treat a generator just like you would your range or dryer if it's not separately derived. And they go, well, how do I know if it's separately derived? Do they switch the neutral? No, the neutral comes to a common terminal bus. Then it's not separately derived. Run 4 conductors. Do it, okay? There you go. All right. Marlon says, I've never had a problem with any inspector once. We bond the bushing, then continue to the ground box. Yeah, I mean, you never had a problem, so I just didn't want to be negative to the guy because what he's focusing on is saying never do this. But I think that the moment you have 6 inches, and it was unbroken, whether it's spliced or not, you had 6 inches, he was just using it for its intended purpose, which was to bond the box. That type of thing. But I'm okay. It's okay. That's what he wants to believe, and that's fine. I don't have a problem with that. And maybe I'm wrong. I might be wrong. Say, Paul, you're wrong. That's okay. I've been wrong before, so it's okay. All right, main bonding jumpers and system bonding jumpers must be made of copper or other corrosion-resistant material. A wire, bus, screw, or similar suitable conductor is acceptable. See these right there? These are just the straps. Some of these you see these straps. I see a lot of what's called. That's right, Thomas. Individual debate is just a debate. Yep. Sometimes people take it way too personal, and I try not to. I just kind of give the code out there and give you my thoughts, and you can agree to disagree. I can tell you that one came from a very lengthy discussion that we had in Code Panel 5 over, I believe it was 251.48 in the discussion, that type of thing. So, whatever. So my main important thing is that you bond the box. I am less concerned, right? I am less concerned with the argument over what the word free conductor is. And if it's such a big deal, then the NEC, somebody needs to submit a definition of free conductor. And that would be easy. Free conductor, at least 6 inches of conductor that is not terminated or used on any termination until after the 6 inches or something like that. That's easy, but that's not what the definition is at this point. So, all right, let's talk about remote panel boards. You know, some people call them sub panels, or remote distribution panel, remote load center, downstream of your service equipment, whatever the hell you want to call them. We'll have the purists out there. Years ago, there was a couple purists who went all over the internet yelling at everybody saying, don't call them sub panels. I don't give a darn whether you call it a sub panel. I'm okay with the term sub panel. It's a sub panel. It's a sub panel. In the hierarchy of life, you've got the service panel and you have a sub panel. I mean, it's a subdirectory of the panel. I'm okay with that. So, but there's some purists out there that say, no, it's no such thing as a sub panel. Whatever. I get it. Or I had one guy say one time, it says the only sub panel is those that are located in a sub. I'm like, whatever, dude. You need to take a chill pill. Okay, so panel board cabinets and panel board frames, if metal, must be in physical contact with one another and must be connected to an equipment grounding conductor. Okay, so in a typical panel board, by the way, you'll see that it is bolted down. It is typically metal to metal. You know what? I don't know if they make any non-metallic. I could be wrong, and I probably am. I don't know if I don't think I've ever seen a non-metallic panel board. I mean, I'm sure they make one, but anyway. So we'll go look at 408.40 because again, we'll just kind of look and see here. But anyway, this is saying panel board cabinets and panel board frames. It's the panel board frame. Okay. And this is the panel board cabinet, okay? If metal, okay? Well, I guess it says if it's metal. If it's not metal, I guess if it's a plastic frame, who cares? If it's plastic, if they make one, who cares? It's only if metal does the actual frame of the panel board, which is this part right here, have to be in intimate contact with the metal frame. Okay. Must be in physical contact with one another and must be connected to an equipment grounding conductor, okay? Equipment grounding conductors must not be connected to a terminal bar provided for grounded conductors or neutral conductors unless the bar is identified for that purpose and is located where interconnection between the equipment grounding conductors and the grounded circuit conductors comply with Article 250.408.40. Okay, long and short, what this is saying, breaking this down so that it's a bunch of word salad. Word salad is that in a remote distribution panel, you run 4 conductors because you want to isolate the equipment grounds away from the grounded neutral conductors, okay? Reasoning for that is obviously that there's going to be return current traveling through the neutral conductors. They're going to be, in the main panel, it's okay because it's all back at the source and it's all returning back. And we bond all the metal parts on the supply side in order to act as one. And we realize that we're only going to be offering overload protection on the supply side of a service disconnect. So it's very common that we do that. It's been accepted practice forever. But on the load side, where it typically gets involved with people coming in contact more with the electrical system, and then there's more devices that plug in and more cords that plug in and all that, we have a little extra precautions that we have to take, and that is that isolation. So you've heard people talk about that all the time, right? Now, in this scenario of this image, so in that remote distribution panel, whether it's in your basement in the same building, or it's in a detached building, and you put that panel in there, when you run those 4 conductors, you're going to have to add an equipment grounding conductor bus, okay? And it gets connected to the metal frame or cabinet of the panel, and then that neutral needs to be isolated, okay? It's another reason why you would not want to use a panel that says something like suitable for use only as service equipment as a remote distribution panel. It can create a problem, okay? So when you put that panel, you want to make sure that you're isolating the neutral bus, okay? But the equipment grounding terminal bar does make intimate contact with the metal frame. And also people ask this question as well when it comes to the grounding electrodes system at that detached structure. Where do you take it? You most certainly never take it except for existing applications in 250.32, which is pre-96 applications. And you have these caveats you have to meet in 250.32. You're not going to meet those caveats in a new installation. It's not going to happen. So when you get here and you do a grounding electrode system, whether you do ground rods, U for grounds, whatever it may be, whatever your fancy, use any of the ones in 250.52, except for the water pipe ground, because then you'll have to supplement it, that type of thing. So say we're doing ground rods. The grounding electrode conductor from the ground rods goes up into the remote distribution panel and it connects to the equipment grounding terminal bus. It does not connect to the neutral terminal bus, okay? So that's what it meant. That's what all that language meant in there, okay? All right, and the bonding jumper, screw, strap, etc. is installed only in the service disconnect mean, not in the remote distribution panel, sub panel, remote load center, whatever your fancy may be. So I see a lot of images online where they leave it, and they leave it in there and they show it as a remote distribution. You could tell because it's 4 conductors coming in. You could tell it's being fed by an SCR, and they take pictures of it and they leave the green screw in there. And I'm like, dude, it's pretty. It may look wonderful. And again, beauty's in the eye of the beholder, but remove that screw before you take any pictures, okay? Because it leaves too much to the imagination, okay? Okay, grounding electrode conductor connections, right? So let's talk now. We talked services. I even went into remote distribution panels or remote load centers. Let's talk a little bit about the grounding electrode conductor connections now, making those GEC connections, okay? So the size of the grounding electrode conductor, that's the GEC, and bonding jumpers, okay? And that would be from, let's say, ground rod to ground rod. That is a bonding jumper. It's connecting 2 ground rods together. They act as one system, okay? That's another misconception that I will just throw out here now for everybody, is if I go from my panel and I'm going down into a ground rod, there are many people that believe that that has to be unbroken because I have to, one ground rod, unless I can show that it's 25 ohms or less, I'm going to supplement it with another ground rod, okay? So you always start off with 2 if you're using ground rods. Start out with 2 unless you can prove 25 ohms or less, then you can drop it down to 1, but you're going to have to prove that. You don't do that with a regular ohm meter, by the way. So assuming that I'm going to put 2, many people think that that grounding electrode conductor has to be unbroken through both of those ground rods. That is not true. Remember, the rule is to the ground rod, that is the rule, that is the GEC, okay? That is the GEC. From that ground rod to the second ground rod is a bonding jumper. Bonding jumpers are not required to be continuous. The grounding electrode conductor is required to be continuous. Okay? So the fact that we're adding this second one is because the original grounding electrode, right, did not meet the 25 ohms. Okay? So yes, so that conductor between the two electrodes becomes the bonding jumper. All right. So going over and looking at the NEC. So again, so we can make sure that's everybody understands what we're talking about. And this is good for topic. Let's look at this requirement. Okay. So let's see here. So we want to look at the installation, grounding electric conductor installation. Okay. So it's the installation real quick. Let's get down real quick to continuous. Okay. All right. Except as provided in 250.30A5 and A6. Okay. All right. Except as provided there. Okay. So that is 3.30, for example, for those that want to know that. That's separately derived systems, right? That type of thing. It says, and in 250.68, the grounding electroconductors shall be installed in one continuous length without a splice or joint. If necessary, splice and the connection shall be made as permitted in the following. Okay, so you have all of these rules right here, right? Now I don't know. I was going to show. No, I don't want to do that. Okay, so if you look at where this rule is under, by the way, okay, it's grounding electroconductor. Okay. So this rule is saying it's continuous, okay? One continuous length, okay? Now, what we're talking about is, let me move back to, hold on here. Okay, so that's not the metal warp pipe. Hold on for a second. Let me get to where I got to get here. Let's see. The eyes. The eyes. Okay. All right. So 250.68, grounding electroconductors and bonding jumper connections to grounding electrodes. Okay. All right. So again, get down here. And so here's the grounding electroconductor connections. Okay, so this is, oh, somebody asked me this the other day. By the way, I'll show you this. Somebody sent me an email and says, when did the 5-foot first come in for connection to the water pipe ground, you know, the entrance, how far? So somebody asked me that. And it was 1993 where the 5-foot from the point of entry actually kind of reared its head into the requirement. That was where it actually first started. Okay. All right, hold on. Let's get back up to, let's go to ground rods real quick. Bear with me. Okay, so this is the installation requirement, okay, for a grounding electrode system installation. So this is for rod, pipe, or plate. All right, so just so we know, we'll go look at the ground rod requirements first. So here is 250.52. This is the different types of electrodes. There's your water pipe ground, in-ground steel, yada, yada, yada. And then we get down to, let's see here, rod and pipes, okay? Now, so this talks about the size of the ground rods, 8 foot, that type of yada, 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 all this type of other stuff, right? So then you get down to the grounding electrode system installation. And this is specific to rod, pipe, and plates, okay? It says rod, pipe, and plate electrodes shall be free from non-conductive coatings, yada, 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 such as paints, and enamel. Rod, pipe, and plate electrodes shall meet the requirements of 250.53A1 through A3. Okay, so again, below permanent moisture level. Yeah, good luck with that. Okay, good luck with that. But, you know, if you do that, great, you're meeting the code. But most of you that drive it just to the surface or leave a little sticking up, which is not 8 feet in direct contact with the earth, probably totally ignore the application where it must be below permanent moisture level. I'm sure everybody ignores that one, but okay. All right, so here, supplement electrode required. Supplement. So it says a single rod or plate electrode shall be supplemented by an additional electrode of the type specified in 250.52A2 through A8. So you can supplement a ground rod or pipe or plate with any of the others in the list. You just can't do A1. You can't supplement a ground rod, pipe, or plate with a water pipe ground. Okay, that's the first thing, right? And it says, the supplement electrode shall be permitted to be bonded to one of the following. So that supplement, let's say you're using another rod. That's your supplement to the rod. Then you're supplementing it with another rod. Okay, so that is your supplemental electrode. Okay, and then you have your exception. It says, if a single rod, pipe, or plate grounding electrode has a resistance to earth of 25 ohms or less, the supplemental electrode shall not be required. Okay, and this just happens to show you an example of how to do a fall of potential to measure ground rods if you don't have one of the clamp-on style. So you have to have some pretty good distance, okay? So basically, the exception is down to 1. So when you run the grounding electroconductor down to the rod, that is your electrode. That is your grounding electrode system. Because you don't meet 25 ohms or less, you're required to supplement that electrode, okay? And so by supplementing it, your grounding electroconductor stops at the first ground rod, and you don't have, you can, if you want to run it straight through all the way to the second one, you save yourself a connector. If you want to do that, that's fine. Maybe save yourself some money, save you a clamp. But nothing says that I can't stop at the first ground rod, put another connector, so you'll have 2 on that ground rod, and then have what's called a bonding jumper over to the other electrode. What did I say, electrode? Nothing says that you can't do that, okay? Now, when they're connected together, they act as one, okay? But there are, let's see. So here, supplemental electrodes. If multiple rods or pipes or plates are installed to meet the requirements of this section, they shall be not less than 6 feet apart. Okay? Again, that's your supplemental electrode. All right? And let's see here. And it's the other thing. Okay. Bonding jumper. The bonding jumper used to connect the grounding electrodes together to form a grounding electrode system shall be installed in accordance with 250.64A, B, and E. Shall be sized in accordance with 250.66. Obviously, the bonding jumper needs to be the same size as the grounding electroconductor. That's what 250.66 is about. Okay. And connected in the same manner. Okay. And no other illustration there. So by proxy of how this works is that I have my grounding electrode, okay, which is my ground rod or pipe or plate, and it's not going to meet 25 ohms or less. Under the exception, it means I have to add an additional one. But the GEC to that rod is the grounding electroconductor. The supplemental electrode that I'm adding, because I can't meet the 25 ohms, okay, remember the ground rod is the electrode. So I'm required to add a supplemental, and it doesn't have to be another ground rod, okay? So the fact that I'm putting one in to meet the rule means that that is a bonding jumper between the two, okay? And I don't know what is going on with my connection to LinkedIn. Seem to have dropped. So if you're on LinkedIn or you were on LinkedIn and you lost me, sorry about that. Not sure why that didn't reconnect. So, hold on here. I'm trying to see if it'll reconnect real quick. Hold on. I don't know if that's going to reconnect or not. I don't know. Hopefully I'm still here. Looks like I'm still here. Not sure why that dropped on LinkedIn. Maybe LinkedIn be hating me. I don't know. So we lost to LinkedIn. LinkedIn went away. That's okay. Probably because I'm over an hour and it's kind of restricted me and say, Paul, stop going over an hour. That type of scenario. So hopefully that makes sense to you. Now, again, if you want to run it continuous all the way through it, then that's fine too. But to me, the grounding electroconductor stops at the first ground rod. Let's see here. The reason we're adding the second one is a supplemental because we can't meet the exception. Let's see here. Okay, let's get right here. Okay, splices. Okay, now if you're going to splice the grounding electroconductor just because it's been cut off, it's too short, it's not long enough, maybe you ran to a UFA ground and somebody cut it off, copper thieves, it is what it is, then you do have the ability to make a splice in the GEC. But it has to be compression type or irreversible. It could be exothermic weld if you want to do that, if you got enough on there to do it, that type of thing, to be able to get it back up there. Okay, you cannot use split bolts for that application, right? For the GEC. Okay, now what's interesting to this, and we'll probably talk about this in upcoming grounding and bonding episodes that we'll be doing, because we are going to start into some grounding and bonding things here on the show as well. But if you have one of the allowances in 250.64 where you can come out, let's say you have multiple disconnects, multiple service disconnects, you have what's called a common grounding electroconductor that is unbroken, that runs to the electrode. But then you have what's called grounding electroconductor taps that can come out of each one of the cabinets and it can actually connect onto that common grounding electroconductor. And those taps do not have to be continuous. They can split bolt onto that common grounding electroconductor. Quite interesting. So if that sounds confusing to you, you're like, well, they allow split bolts there, but they don't allow it to the common. Yes. And they don't allow it to a single service where you have a GEC that's running down to the electrode. Grounding electroconductor. Okay. Now, the other thing, yeah, tell me we haven't seen that. Smashing the ends of the split bolt down is not reversible? No, it wouldn't be, but you'd be surprised the number of pictures. I can't find them. I used to have a bunch of pictures of a split bolt, people trying to get 3 conductors in a split bolt that was designed for 2. And then I had pictures of them torquing it or doing it so tight that it literally crushed the conductors. And it almost acted like it was it was one conductor or something like that. That's kind of crazy. I used to have, I don't know where those are. I had them years ago. And the funny part about it is they got approved by the inspectors, that type of thing. So that's kind of a scary thought. Let's see here. Where else? All right. So let's go on. So this is not, but this is an example where it's a crimp, irreversible type of crimp, or exothermic welding, CAD welding. I have only done it 3 times in my career. I've only had to do it. And 2 of the times because we had the wire in place and an excavator or some other piece of equipment hit it and damaged it, but it was still long enough and we did not want to, it was a UFER and we're like, dude, we just ended up using exothermic welding. That's the only time. 2 of those times was that. The other time was an irreversible crimp. And that again was because it was a theft situation. Other than that, I don't see the need. The GECs are run and that's fine. Now, one thing we can look at, by the way, if we want to look at it, is I love learning stuff. So let's see here. Well, let's go real quick. And I cannot overstate the importance of solder everything. Solder cannot be used as the only means in many cases. So let's see here. That's an interesting story I can tell you about soldering. That I used to solder a lot of joints in a house because again, I could wire nut, but I used to use solder, and you can solder everything. Hot conductors, neutral conductors, wrap with electrical tape. It's equivalent. Not use wire nuts, whatever. It breaks the monotony of an installation. Every now and then I would solder, but the irony is you can't do that for the equipment grounds. You can't solder them, but you can solder the ungrounded and grounded. Kind of interesting. Maybe we'll talk about that one day. My brother got in trouble for that because he was soldering his equipment grounds and an inspector pointed it out and he called me and I told him, I said, no, you can't solder the equipment grounds. You mechanically make them up first, and then you apply solder. Solder alone can never be used as the sole means. But if you pre-twist the conductors, then they're mechanically connected. Then they're together. They're not coming apart. Then you can solder, but you can't do that for the equipment grounds. Interesting. We'll maybe talk about that one day. All right. So anyway, where was I? I wanted to go look at. What was I going to look at real quick? See how my mind. Oh, grounding electroconductor. Sorry. So I want to go look at the conductors and just kind of, let me get down. Oops, let me get down here. Okay, grounding conductor. Let's see here. Equipment ground. Let's see here. Okay, grounding electro, EGC. Let's just, GEC, excuse me. All right, so let's get right here. We have this little, again, you got your little acronyms, that type of thing. So what is the grounding electroconductor? It's a conductor used to connect the system's grounded conductor, that's back at the neutral, okay, or the equipment conductor or the equipment. So in a remote distribution panel, it's the equipment grounding that connects to it, or in a service panel, it's the grounded conductor that connects. Okay, it uses it to connect that to the grounding electrode, or to a point on the grounding electrode system. Notice it's not plural, okay? So the grounding electrode, when we install one ground rod, that is your electrode. The fact that we're installing another electrode is because we can't meet the exception to be 25 ohms or less, so we have to supplement it. Another good example of that is the water pipe ground. So the grounding electroconductor to the water pipe is the grounding electroconductor to the water pipe. You don't continue past the water pipe and then go and hit another electrode with an unbroken. No, you go to the water pipe, you make that connection with 5 foot of point of entry, assuming that your water pipe meets the requirements of 250.52A1, means 10 feet in contact with the earth. Assuming you have a water pipe grounding electrode, okay, I have to supplement that with one of the other types of electrodes. Typically, people supplement it with ground rods, right? Just remember that you can't supplement a water pipe with a single ground rod unless that single ground rod meets 25 ohms or less. Then you're going to have to put 2, right? So under that logic, if it had to be continuously unbroken, then you're saying that it has to go to the water pipe, then loop through the water pipe, then go to the ground rod, then loop through that and go to the other ground rod. That is not the intent, okay? So it is unbroken continuously to the electrode. The fact that it's being supplemented means that we can put a different clamp on it and we can go to the supplemented electrode, and together they act as one. But we've met the requirement for the GEC to go from the neutral or the grounded terminal to the electrode, period. The fact that we have to supplement it is just a code, and that's part of the prescriptive requirements of Article 250 in order to meet the performance requirements in 250.4. God, that's a lot. I was waiting for Thomas to tell me I'm in an IRC or an IBC document, because that's how it sounds, right? But that's how 250 works, by the way. Okay. So hopefully you're getting something out of this today. It's a lot of info. Hopefully you're getting something out of it. All right, so we're going to do this here. We've talked about the ground latch, so we're going to stop the methods of bonding at the service, and we're going to pick up that tomorrow. Okay, there you go. Let's see here. What does Adam say? I just want to say a ton in this, learned a lot in this lesson. Much appreciated. Look forward to the grounding and bonding lessons. Oh yeah, a lot of people want our grounding and bonding stuff. So I am planning on bringing grounding and bonding to coffee hour. And we're going to be talking a lot about it because there are a lot of misconceptions about grounding and bonding. It's okay. It's perfectly fine to do that. Interesting. One thing we'll clear up real quick before we leave today is just to look at a picture really quick, and at least you're going to leave with the understanding of what the difference between a concentric and an eccentric KO is. Because again, I am sure that people wonder, okay, which is which? Which is which? Okay, so I'm going to paint this visual, and you'll never forget again. There you go. Concentrics starts in the center, and all of them come out in circles. Boom, 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 boom. That's called concentric. Eccentric or eccentric, however you want to pronounce it, is when you have one that's off center and then it has different half moons that come out of it. Okay? These typically right here, concentrics, very rarely are rated for the over 250 volts. They could be, right? Could be, but very rarely are. I'm not saying never, but usually it's these eccentrics that are rated for over 250. I know somebody proved me wrong, but typically these are a little more welded. Instead, these usually have just a one little weld here and here, and these tend to be a little more area, okay? So again, not always, but important for me to let you know the difference between concentric and eccentric knockouts, okay? Now, yeah, as you can see, what we're gonna get into tomorrow is we're gonna talk about the different methods of bonding at the service. I have a great presentation of this over on Fast Tracks Tube as well as in our YouTube channel, but again, we're gonna get into that, okay? Are you going to show us the excavator video? I do have a little I got what's called a YouTube short. Go watch it on my YouTube channel. I do have a little short showing my excavator. I do have that up on YouTube, so you can see me digging. But it has been nothing but a muddy mess the last couple of days, so I have not done anything. It's just too muddy to do anything. And I know mud wipes off. I get it. But you know what? I'm anal about it, and I just don't want to go playing in the mud. It's nasty. Okay, it gets all up in the tracks, and it's just nasty. All right, let's do some giveaways real quick today. Let's spin the wheel, do some stuff. Y'all have been patient. I'm long as normal. I am over the time as normal. There's no way that I can stick to any time frame. I can call it coffee hour all I want, but JPB. JPB, you get Fast Tracks Tube immediately. If you already have it, then we will add a year onto it, or we will spin again if you already have it. But that is a subscription over on Fast Tracks Tube. Just go to fasttrackstube.com, fasttrackstube.com. Go on the top where it says member plans, click the free plan, sign up, then send us an email, let us know that you signed up for it, and we will get you elevated to your 12 months of access to Fast Tracks Tube. I know, pause. Coffee hours plural, hashtag. I try to be good stewards of you guys' time. I know it's in the morning. I know that if you work for somebody, I'll let you working to get it. Anselmo Ciro. All right, you are in the drawing for the voltage drop card. I don't have an example. Well, wait a minute. Yeah, I do. Here's the voltage drop card. Neat card, okay? It is thick. It is not going to break down. It is heavy duty, and you're in the drawing to win one of these. If y'all want one, you go to our website, you can buy them. Great gifts, great to keep in your wallet. Voltage drop, again, not a mandate in the National Electrical Code, except for sensitive electronic equipment and fire pump applications. Certainly in those applications, it's not 3% and 5% voltage drop that we're familiar with under the informational notes in 210 and 215 and in 230. But it is good advice. And again, many things can go wrong in a system if you don't take into consideration what the end voltage is, especially if you have a piece of equipment that operates under a voltage window, and that voltage drop could cause it to operate outside of the scope. You could void, maybe it doesn't cause a problem with the system because the breaker may trip, something may happen, something may overload, and you have protection. But have you ever thought of the fact that if I'm a manufacturer of a piece of equipment, and let's say it's an expensive piece of equipment. I mean, let me be a devil's advocate. We're going to spend a couple more times here. But I'd be a devil's advocate here. If I'm a manufacturer of a product, and for some reason, if I were to have a piece of equipment that failed, and I happen to send a technician out there because it's expensive equipment, maybe it's a CNC machine or a lathe or something expensive, I might send a third party. I might hire an electrician as a third party, pay them $125 their hour fee to go out there and measure the voltage drop. Just talking out my butt here. If I'm a manufacturer who's not one of those that just say, you know what, the customer's always right, I'll give you a new one. But no, if this thing is $30,000, $40,000, and you didn't take voltage drop into consideration, let's just be a devil's advocate. Maybe that's a side hustle for some of you out there. All right, you get called and you go out there. Somebody's going to start this side hustle. Somebody's going to start this contacting big manufacturers of equipment and say, hey, if somebody files a claim that burn up, I'm going to go out. So if I go out there and I measure the voltage drop, and what if the voltage drop is below the operating parameters on the nameplate of the equipment? What if it says that it needs to be a certain voltage and it drops below it? And now I report that back to the manufacturer and say, you know what, it's supposed to have a minimum of 110 to 130, whatever the window would be. And I measured it at less than that. And I used a Sure test or something, pretty reliable device. Is it a possibility that manufacturer could say you voided the warranty because you operating it below a voltage level, and maybe it has some type of effect on the equipment? I don't know. It'll be up to you to prove otherwise, right? I mean, y'all know that I do a lot of stuff with in courts and expert witness. I can build a case around that so that the manufacturer would not have to cover the warranty. That sounds like crap, but you see what I'm going? So it's still a good idea to do it, right? I can tell you one thing that I ran into that I think voltage drop does impact, but I can't tell you with 100% certainty because I didn't go back to do this. But AFCI devices and GFCI devices, mainly the AFCI in my situation, in a house in Oklahoma that had an issue, there was a lawsuit going on, and I was deposed. I was giving expert witness testimony to the fact that this electrician ran really, really long circuits. And when I say long, I'm talking probably to get there, just to get to that side. Poor design, okay? But again, I'm not going to judge. Just to get to that side of the building, they probably ran 14.2, for example, which I have no problem with. Just to get there, they probably ran, I'm going to venture to say, 225 feet. I'm not shitting you. Just to get there. So they didn't put a remote panel somewhere to shorten the distance. That's just to get there. And then it ran around the bedroom and all this kind of stuff. And the AFCIs would not hold. And so they replaced stuff, replaced new AFCIs, pulled all the circuits open. There was nothing touched in. Once the home run was tested out, there was nothing that was wrong with anything. It's just the distance. The moment they put the AFCIs on it, they kept having problems. It would work for a little while. Then they'd have to change. So the guy had literally a bucket of air. He was rich anyway, by the way. He's probably one of the richest dudes in Oklahoma. Okay, he helped develop some software for the government. Long story. Really down to earth guy though. Neat to meet. But anyway, up near Oklahoma City. Anyway, I was up there. I was called in, and that link was so bad that I think, and I have yet to have the manufacturer say anything about this, does the length or voltage drop? And as a manufacturer of wire, we just make wire. But it would be nice for a manufacturer that makes those devices to say, no, there's no length, that's not going to cause any problem. Well, if I have a really long run and it is AC, so we know that there's impedance involved, okay? In all this long distance, could that have been the reason that the AFCIs kept failing? And it wasn't just that one circuit, it was multiples that were all coincidentally the long run. Now you might be saying, well, it's probably just a nail driven in or staple driven in. It could be, but we didn't measure that when the electricians measured the distance. It was the key issue was the voltage at the end, okay? And obviously, when you have voltage drop, it's going to affect the current as well, okay? So they're all a voltage to current relationship. So at the end of the day, and you can find this out by just doing voltage drop calculations. You can find this out by doing Ohm's law calculations and with resistance and change and vary the voltage. You'd be surprised. So I am not sure. Now, for regular residential, this should never be an issue because I'm just saying. But if you do, dude, put in some remote distribution panels. You should have done that anyway. Who the hell wants to run home runs 200 plus feet? and especially being 14.2. I have no problem with 14.2, but dude, over 200-foot home runs, you're just asking for trouble. That's like sitting there. That's like a cable that's sitting there going, screw me, screw me. You know, not me, buddy. I'm going to design that much differently. So I did say that, but I said that to the electrical contractor. So I was like, you need to rethink that design. But I'm not a hater. You do you, boo. But I'm just saying, think about it. But so that's where voltage drop could play an issue. What do we got? BB says, first time catching the live. Love the commentary. Thanks for joining. Glad to have you here. LJ says, is it considered concentric if you if you sell people a course to obtain a certification for a board on which you sit? No, because I don't know of anybody that sits on those types of boards. I serve on a code making panel board. I don't sit on a certification board for anything. So I don't know. But if you actually sit on a board or you do, that's probably why I don't serve on Texas's development for exam prep, because they feel that we may help people pass the exam. So I don't do it. So you may be implying that, but no, I don't. I don't sit on any committee that has a certification. The NFPA's committee code panels are for the development of the National Electrical Code. And Mike Holt, Ryan Jackson, tons of folks teach courses to help you better understand the NEC, to help prepare you to take that exam. But and also, it's important to understand the difference. Certification is not the same thing as licensure. Big difference, right? All right, so let's get back to spinning the wheel. Let's see here. Actually did a podcast explaining licensure, certification. JPB, conductor length card. You're cleaning up today, Jay. You got Fast Tracks tube and you're getting on a drawing for conductor length. Oh, it's rolled, but I saw you there. So I'm going to use you. It's stuck there for a sector, so I'm going to let you get it, JPB. You're in the drawing for that conductor length card. Even though it started rolling again, it kind of lost its lock. There you go. So congratulations for that, JPB. You're going to be in that drawing. Pause it. Looks like everybody wins. Well, it's kind of like a putt. It laid on the lip long enough for JPB, so we're giving it to JPB. All right, new plays. I don't know if you already have a Fast Tracks Tube subscription, but if you don't, go over to fasttrackstube.com, go up to the top where it says member plans, click on it and go down, put in your information, choose the free membership. Once you sign up and get your username, email us and let us know it is you, and we will elevate you up to get 12 months of access. And you can get the interactive videos as well and all the new stuff that we've got coming. Jeff has not released the date yet, but we have some stuff that are already in the can that we're going to be releasing over there, type of thing. All right, folks, let's get back to the main. And here we are. And again, like I say, there's always a world of smart asses out there who think they get people, but they're not intelligent enough to read through the question and understand it. So again, sorry, it sucks to be that much hate inside your world, but is what it is. All right, folks, till next time, stay safe. God bless. Catch us tomorrow as we're going to talk about methods of bonding at the service. And we're also going to talk about grounding electrode systems a little bit and even get deeper into things like water pipe, rod, pipe or plates. And we're going to talk about those conductors. And we will talk about, like I said, when you have a ferrous metal raceway, the connection on each end. So make sure you follow that, okay? And we're going to be talking about sizing of grounding electroconductors. And again, the ability to use 250.66 A, B, and C as not exceptions, but allowances in lieu of using 250.66 the table, that type of thing. So we're going to be covering all of that. And we even may touch on supply side bonding. So tomorrow's Friday. Next week, I think we're going to do Let's Ask Paul Friday. But tomorrow, we're going to try to end this And so it may be a long one. So buckle up. Make sure you join me tomorrow on the 16th, because we're going to cover a lot of stuff very quickly, because I want to end this Friday. Okay, so it's a lot of stuff we got to cover. All right, folks. Till next time, stay safe. God bless. I appreciate you all. Thanks for joining me, and we'll catch you on another episode of Coffee Hour. Take care.